Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 80. Myself, Anshika Jain, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th February 2024, and the virtual event is being held through the Zoom today and yesterday is 21st and 22nd of February 2024. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. Coming to the guidelines, in this session, we have 6 presentations and each presenter would be given 12 minutes for the presentation and 2 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants to stay connected to us till the closing remarks. If you have any queries or any update, you can write it to me in the chat box below. So just before we get started, I would like to introduce you to the chair of the session. We have our session chair, Dr. Priyanka Verma. She is an experienced educator and trainer in the area of lecturing and technology with a track record of working in the higher education industry. Ma'am is skilled in computer networking, Microsoft Excel, communication skills, leadership skills, creative thinking, teamwork, critical analysis, and problem solving. Strong consultancy professional, graduated from the Institute of Engineering, Kolkata, and National School. Currently working as a professor since May 2015 to till date. She is also a part-time researcher on data science. Welcome to the session, ma'am. Would you like to share a quick opening remark with us? Okay, I think ma'am's network is a little weak, so we'll move on with the presentations. So first, we have our first presenter who has a paper titled on a case study of student performance predictions in English course, the data mining approach. Are you there, sir?
Hi everyone, can you hear me?
Yes, sir. You are audible. You may start with your presentation.
Okay, I will share my screen. Can you allow the permission for me to share screen?
So I have given you the permission. You may start.
Okay, thank you very much. Yeah, I have it now. Okay, so can you see my screen now?
Yes, sir. We can see your screen. You may start.
Okay, so hello everyone. So on behalf of the authors, I will present my papers, a case study student performance predictions in English score, the data mining approach. So my name is Dong. So the content of my presentation, it has a 5-part introduction, and I will prepare the data processing, the experimental and setting, and the result. And finally, I will draw the conclusion. So for the prompt, I will introduce about the international school. Is a school in Vietnam National University. And here we offer a lot of courses and major, and all of the major are taught in English. So um, recently we have received a lot of students, so it may be pose a lot of challenges for us, and especially here because all of the course we taught in English, so we required the student need to have a certificate for English, for example, like B2 IELTS or TOEIC or TOEFL. So if the student do not have a certificate, so they have to enroll the preparatory training program, and in here we want to place the student into the level, the foundation 1, foundation 2, and foundation 3 and 4. So we need to evaluate the student when they do not have the certificate to place at the correct level. Okay. So here, that is the pathway for the student when they enroll to the preparatory. So we have the student will take and intake. So they will study continuously until they have the certificate. If they do not, so they need to take the intake again and until they have the certificate. So after that, they will enjoy to learn the curriculum course. So we need to we want to take all of the information of the student in the prepared program to check and to some kind of to take a look deeply. So we want to predict based on the information of the student. So maybe we want to apply the data mining. So to check the student, the level of the student before they enroll. So may have to for the academic affair to prepare before they launch the preparatory program. So in this work, we will the first of all we will take a look at the data and answer some questions. So, for example, like what the factor will affect to the student learning English, and also maybe we take a look at the place of birth, the gender, or the others can some kind of to affect to the student learning. And after that, we will draw some conclusions, and then we applied the machine learning model. And here we just apply some basic machine learning model because we just have 1,000 records of the data. So maybe we will not need to use the deep learning. So here, that is an example of the data. All of them that is in Vietnamese. So, for example, here that is the student is the female, and she have the certificate at December of 2020. So she begin at the level 1, and she need to take some kind of the intake from 1 to 20 to 14, and and she attend after over 10 intake, so she have the certificate after that. So maybe 14 intake, so take so the time is some kind of 7 months. Um so because the data we take from the academic affairs, so it has a lot of noises and it has a lot of irrelevant information. So we just drop on of the record that is not some kind of to have it for mining the data. So finally, we just have some kind of 893 records. For the data preprocessing, actually, the data is very noise. So we have to some kind of to correct the information manually. For example, here I just take example because we typing in the Vietnamese. So for example, here we have the TP Hanoi. That means that is Hanoi City, and here they type time for Hanoi. That mean also mean Hanoi City and so on. So we need to correct and to put it in the same level. For example, the Hanoi City, for example, like that. Also, we group the data because we think that is it for example, like here, the plate of birth that is quite specific when we want when we use the city. So we group into some kind of to for the regional. For example, here we have the northeast, west, the northeast, and the red river delta, and so on, and central. So by doing this, we can some kind of to make the information more general. So for the um, mining stuff, we some kind of use a EDA. For example, here we can see that here the subject group, that is the ancient exam to go to the university. For example, here we have the group in A00. That means the student uh, will have the exam in maths, physics, and English. Here we can see that that is the level is quite some kind of quite good, because I think that because the A00 it has the English score. However, uh, in the A01, that is some kind of math and physics and another subject to go to the university. It has some kind of quite the same, and especially the social that mean they will take some subject, for example, like that is not some kind of English course, it's not some kind of math. It has a social subject, so it take 500 records. So most of the students that need to take the preparatory score program that is come from the social group, as you can see here. And also for the reason, so it is quite a surprise for us, because the student come from Hanoi. It takes some kind of 200. That means it is there are quite a lot of the students from Hanoi. That means the capital city, because in the capital city, they also they should have a more educated than the other. For example, like the Delta, from the Delta River, and also from the central here, but they have quite a lot of the students here to have to learn the English. Um, and from the Delta River, yes, most of the students go to Hanoi to study, that they come from the Delta River. So that is quite common for us. But that only this one from the student from Hanoi, from the capital city. Mm. And from the major ties, that means the student apply to the university for the major. So from here, most of the student from the IT major, that they need to learn the English again.
Sorry to interrupt you, sir.
Yeah,
Sorry to interrupt you, but you have 2 minutes to conclude your presentation, sir.
yeah. Thank you very much. Okay, so yes, so to apply the machine learning, we here we will group the student performance into 3 groups. That means the student will learn fast, slow, and medium. So we want to predict the students, so they will learn fast, slow, or medium from the data. And because the data is quite, you can see from here, the data from quite imbalanced, so we need to apply the over sampling before we apply it to the machine learning model. And then we just use the accuracy and F1 score to report the results. So the result from here, we see that the voting is quite good for overall the other model. The voting here, or actually we use the random forest and SVM together, and you can see from here the F1, actually the F1 that is the most important one. So we want to focus on the F1s here. is actually is higher than the other. So maybe for the future work, we will still go to deeply for the voting to increase the performance. So yeah, so by explore the data from the academic affair, we have some insight for in the data for the student to learn the preparatory program in our school. And also, we will apply the machine learning model, and then the voting algorithms has a good result. So for the future work, we will continue to invest more for the voting model, and also maybe we will try to apply the new loss functions to improve the performance of the model. Thank you very much. And for the question, can you ask me? Thank you.
Thank you so much, sir, for your presentation. Ma'am, do
Yes.
you have any questions?
Yeah, I have a question. You mentioned about pre-processing, right? So, did you use any specific algorithm to perform this pre-processing?
For the algorithm for to choose the pre-processing, right? Actually, yes, we apply a lot of algorithm to choose for the data processing. For example, as I said, after manually group the data, and actually we have to some kind of multiple like many features together to yield to make a new feature. And also we also compare the one hot encoding and also the ordinal encoding and so on. And finally, we come up with the one hot encoding to encode the data. And actually,
And
the
this
data processing.
voting algorithm that you have used, it's actually a combination of certain algorithms.
Actually, if I understand the idea, mean the some algorithm like the model, right? Actually, no. The data processing here, we just apply some technique. Actually, as I said, the technique that is more correctly. Yes.
Okay, thank you.
Yeah. Thank you very much. Yes.
Thank you so much, sir. So we'll be moving
Yes.
on to the next presentation now. Next up, we have a presenter presenting on the paper titled Binary Segmentation of Malaria Parasites Using Unit Segmentation Approach. Are you there, ma'am?
Can you
Yes,
repeat
I'm
this?
here. Yes, I'm here.
Okay, you may start your presentation, ma'am.
Okay, thank you. I hope you can all see my screen.
Yes, ma'am, we can see your screen.
Okay.
You may start now.
Okay, so my name is Eugenia Mawenyaku, and I'm talking to you today about binary segmentation of malaria parasites using unit segmentation approach. And this is a case study in Rwanda. So malaria is a deadly disease that is caused by the bite of a female Anopheles mosquito. And mostly the symptoms include fever, headache, chills, vomiting, anemia, diarrhea. This is just a few amongst many. And in 2020, as of 2020, we've had like 241 million infections globally with 627,000 deaths. And Africa recorded the highest number of cases and fatalities. And there are so many ways of doing the malaria diagnosis, but the light microscopy is the gold standard because it's able to give you details about the parasites involved. Okay. But what's the problem? The problem is that light microscopy can be quite time consuming, and the result is always, the accuracy of the results is always based on the skill of the operator. And there are some settings or areas that do not have this resource, right? So the previous research, many people have tried to automate the malaria diagnosis process, okay, using advanced image analysis software and machine learning. Some of the machine learning models that have been used are YOLO V4, YOLO V5. Others have also used the nearest neighbor, logistic regression, and more. But most of them have focused on one type of parasite, and that's mainly is a notable gap that we have. And so the study for this presentation is also is motivated from this system, an automated malaria diagnosis system, basically in Rwanda. And what we aim to do is, so we have like the network medical centers, basically the hospitals and the labs. We collect digital data and then it's delivered to the health data office. The data is also saved in a database for pre-processing and any other things that need to be done from there. Then we have the data repository, where the machine learning processing and then treatment recommendation is done, and then the result is sent back to the health data office, is delivered back to the medical center. We also hope to have like a public interface, like where authenticated public can have access to statistics about malaria, basically. So the objective of this study is stemming from the data repository I mentioned earlier. We are doing a machine learning analysis. So we explore the application of semantic segmentation to specifically the unit architecture to for malaria plasmodium species segmentation, right? And we also hope to address the gap that I mentioned earlier in the existing research, including data composition, primarily consisting of thin images, and the lack of studies on the diverse species of malaria parasites. I'll be talking about the different types of malaria parasites shortly. So we are contributing to the data repository aspect of the motivating system I mentioned. So basically, we work with the Rwanda Biomedical Center, and in our investigative phase, they are acting like the health data office to us. So there's the sample smear, the smear starts delivered to them, right? Where the blood, we don't deal directly with the blood though. And we have, this is how our setup looks like. So we have a camera that's attached to a microscope, and then we have a third-party software where which we use to take the data, basically. So there are 4 types of parasites we are dealing with, especially in Africa. We have the Plasmodium falciparum, Plasmodium malariae, the Plasmodium ovale, and then the Plasmodium vivax. Now for our data sets, basically the images that were captured, we included thick and thin film smears. And then we use the VGG image annotator to annotate them using the polygon tool. The images and the mask, that was the images and the mask were resized to a uniform dimension of 256 by 256. And that was just the basic pre-processing that was done to it. At the time of this study, the data set was split into 80, 10, 10 for percentage, for train, validation, and test. So the model that we are studying, we use the UNET architecture. So the UNET is a convolutional neural network architecture that is designed specifically for biomedical image segmentation tasks. And so how it works basically is that we try to capture the hierarchical features whilst reducing the spatial dimensions. So the hierarchical features here is referring to the parasites that we see in the image that it's given. And then we focus on that and then recover the spatial resolution of that segmented region. So at the end of the day, the image that you should get should only have the parasites in the background, basically. And we did that separately for the 4 different parasites. So for model training, because of the size of the data set, we use the batch size of 16 and an epoch size of 300. We use the binary cross entropy loss function and then the Adam optimizer. But for training, we just focus on the accuracy. Then for testing, we use similar metrics, but then we added the precision, the recall, and the F1 score. And then we used the only hyperparameter tuning that was done was for thresholds for the metrics that I mentioned, the precision, recall, and F1 score. And so this is the results we got. So the total here refers to the total number of images, including training, testing, everything. And these are the loss values. But if you look closely, you realize that with a small number of data sets, the accuracy for falciparum is quite high. And so there's this anomaly in the metric that has been measured. And so we consider the F1 score, which is the harmonic mean of the precision and recall. And we realize that it's in correspondence to the total number of images that were passed to the model. So here you'd realize Ovale had quite high F1 score, followed closely by Vivax, malaria before falciparum. But if we look at the images, like the visual results, you'd realize that the results are quite precise in the sense that if you look at it, if you look at the image, you can clearly see the nucleus of the parasite. This is Plasmodium falciparum, and the model segmentation tries to capture that. And so it's one of the things that looks positive from this study, but still the F1 score is too low. For malaria, we also experienced that the image, the model segmentation gives us a fine outline as well, compared to the hand annotation that we made. And the result is similar for the rest of the parasites as well. And so what do we take from this study? Realize that we still lack the comprehensive data set that encompasses the wide range of parasite variants, and especially for falciparum. And so there's an ongoing process of trying to capture more detailed data for further processing. It's also important, like I mentioned, you realize that the model segmentation was given quite fine outlines than even the hand annotations that we made for the mask. And so if we could use computer vision and image processing techniques to extract ground truth mask, that will improve the F1 score as well. We also hope to explore other loss functions and metrics. And there's an ongoing work using the mask RCNN. And why are we using the mask RCNN? So in the malaria diagnosis process, there's the need to also check the severity of the malaria diagnosis that you are trying to make. So if you find that the person has maybe Plasmodium falciparum in their blood, you also count the number of times these parasites are occurring. There's a way to do that. And so with mask RCNN is instance segmentation type. And so when we are able to get the instances as well, not just the segmentation of the parasite, but the instances, would be able to safely deliver the severity of the malaria parasite. Yeah, thank you. Any questions for me?
Thank you so much for the presentation, ma'am. Ma'am, do you have any questions?
Yeah, I have a question. You
Yes,
said that you
ma'am, go ahead.
collected the data from some lab, right? You mentioned in your presentation.
Yes, the Rwanda Biomedical Center.
Yeah. But then you said that data collection was an issue. So,
Okay. So
like because yeah.
when we say data collection was an issue, as we are in the investigative phase of this, the data repository part of the system. And so as at the time the study was done, by the time, so what the lab does is they don't get the direct patients to actually take the blood samples from and prepare the slides. So they go to their field to do that. And we all understand that it comes with ethical issues. And so by the time, sometimes by the time you take all of the images, delete the ones that were not taken very well, you end up having small images. But at this point, as I'm talking to you now, we have increased that data set. And so we are hoping to get about 500 each of the parasites, and even more so to have like we have the mixed infections where there are about two parasites coexisting within a person's blood. We also hope to get 500 of that. Then we can make quite improved model systems for that.
Okay, and what exactly is the purpose? Because you said that in your Africa, the cases are too many for malaria, right? So why exactly
Yes.
are you performing this study? I mean, what exactly is your purpose?
So the study, I remember here I mentioned that it's quite time consuming. So when you go to the clinic here in Rwanda, when you go to the clinic, after your blood sample is taken, you're asked to wait for 2 to 3 hours. But then with the automated diagnosis system, you don't have to wait for that long. It will just take a few minutes to get your results, very accurate results, and with the recommended treatments. So the system will
Okay.
also recommend treatments for you. Yes.
Okay, so to give improved treatment, that's why you are focusing on this research.
Yes.
Okay, okay, thank you.
Thank you so much, ma'am, for your presentation.
Thank you too.
We would be moving to the next presentation. Next, we have Dimitru to present his paper titled Digital Images Augmentation Using Mathematical Morphology Operators. Are you there, sir?
Yes, I'm here. Can you hear me?
Yes, sir, we can hear you. You may start with your presentation, sir.
If you are kind to, I will share my screen if it's possible.
Yes, sir, you can share your screen now.
Yes, it's the screen shared. Can you tell me?
Not yet, sir.
Not yet. I'm trying to figure out why. What about now? It's my
Yes, sir. Yes, sir. Now
yes.
your screen is visible.
Okay, so my paperwork, my article, it's entitled Digital Images Augmentation Using Mathematical Morphology Operators. Um, uh, Second, my goal is to evaluate the impact of mathematical morphology operators used on digital image to achieve if the data set of images can be improved or not. In my work, we will see if these mathematical morphology operators used on a data set of images have an effect or not. For this, I got a image data set consists of 40,000 images with two sets of images. One set of images consists in 20,000 images with defects, civil works defects such as cracks, and the one folder contains 20,000 images, also with civil works images, which have no kind of defect. Each image resolution consists in a resolution of 224 or 224 pixels, and all images are RGB images. To test the mathematical morphology operators, I create a convolutional neural network. As we see, this convolutional neural network has five uh, layers. Each layers and for each layer, I define the filter size and the number of filters. Uh, first, first checking which I did, I checked the images on the size on the this size. Uh, I checked the image size as you see in the first before mathematical morphology augmentation, it has without defects 152 megabytes and with defects 164 megabytes. After I did the augmentation, each data set was reduced as you can see in this image. The mathematical morphology operators consist in four types of operators called erosion, dilation, opening, and closing. Opening operator means that first time it's made an erosion operation, which followed by a dilation operation. Closings mean a dilation followed by an erosion. Uh, as you can see in the images A and B, it's the effect of the opening operator. From this operator's test on the data set of images, it was concluded that only the opening operator is suitable in this case of image improvement. after I tested my convolutional neural network, each set of images, you can see that without augmentation, the accuracy is 99.31%, and using mathematical morphology operators, the accuracy increase. It's not a huge increasement, but it's 0.17%. And also the training time measured in minutes, it was reduced from 218 minutes to 194 minutes. As a conclusion, as you can see in my previous images, it is demonstrated that using mathematical morphology operator increase the data set by reducing the images. Also, the images was not affected. The accuracy of the convolutional neural network increased, and also the training time was reduced. Taking in consideration all these aspects mentioned above, it is expected that using opening operator as an augmentation tool to be extended in other kind of tools. This kind of augmentation, it's for me, it's important. For example, in case of a natural disaster or such as an earthquake, you can check the damages using a drone to capture the images, and after that to test how much was the constructions or road structures affected by this kind of an earthquake, this kind of natural disaster using this kind of mathematical morphology operators. This is in this slide, you can see the author of this article, and due to the fact that I tried to be as short as possible, I thank you for your attention, and I'm glad to answer to any questions of you if there are any.
Thank you so much for your presentation, sir. Ma'am, do you have any questions?
Yeah, I just want to know, why did you use CNN only? I mean, was there any specific reason for choosing this algorithm?
In this stage, I use convolutional neural networks, but I have a next article where I use pre-trained neural networks, and I can say that it's better that my algorithm used in this article.
No, but did you perform some research sorts, as in did you compare CNN with other algorithms as well?
No, the only comparison what I made was without mathematical morphology augmentation and after mathematical morphology augmentation. This is the only comparison which I made in this case.
Okay, so my suggestion is that before you propose any particular algorithm, you must always compare it with other algorithms as well, so that you can always prove your point that CNN was actually the right algorithm for your data set.
Okay, thank you very much.
Okay, thank you.
Thank you so much, sir, for your presentation. Now we would like to move on to the next presentation. Next up, we have our presenter to present the paper titled Learner-Centered Learning Activity Support Service based on push messages. Are you there, sir? Are you there, sir? So we will move on to the next presentation. We have our next presenter whose paper is titled Multi-Hop Wireless Network for Residential DC Microgrid Energy Management. Are you there, sir?
Yes, I'm here.
Yeah, sir. You are audible. You may start your presentation.
Okay, I'm just trying to share my screen.
Yes, sir. Sure.
Okay, can you see it?
Not yet, sir. Yes, sir. Now I can see your screen. You may start the presentation.
Okay, good evening. My name is Fani Masango from South Africa. I will be presenting the multi-hop wireless networks for residential DC microgrid energy management systems. Just excuse me. This is my introduction, my table of contents. So I will go over the introduction and then the review of microgrid communication platforms, the methodology on the integration of multi-hop wireless networks for the residential DC microgrid. And I will also go through the results of the simulated microgrid and the future research. The population problems caused by non-renewable fuels have accelerated the use of distributed energy resources, and microgrids in all industry. In the past few years, the merging of renewable energy resources and smart grid technology has transformed the energy scene, especially within the residential environments. A notable progress in this field involves implementing wireless networks to oversee energy management within DC microgrids. The diagrams displayed here shows 4 residential units or nodes and the solar farm. The units and the solar farms are electrically connected to form a microgrid. Communication among these nodes within the microgrid supports effective energy management, thereby enhancing reliability, resilience, and sustainability. When resources are distributed within a microgrid, significant fluctuation in load generation, capacity, and storage can occur. To ensure the stability of the microgrid, a control system is necessary to sustain bus voltage at a consistent level for extended periods, especially during instances of load demand surpassing the generation capacity. Figure 5 on the right shows a type of control scheme that incorporates a master-slave configuration. The master controller, which is situated at the solar farm, sends commands or directives to the slave controller, which is the residential units, which then carry out the specified actions. To guarantee optimal grid performance and reliability, it is important that the communication between the master and the slave's components not only remains reliable, but also operates seamlessly. This paper explores the implementation and benefits of a multi-hop wireless networks in a residential DC microgrid energy management, also shedding the light on transformative potential in shaping the future of residential energy systems. Table 1, shown on the right, exhibits the wireless communication technology evaluated for grid systems by these authors, Dinesh and his colleagues. The table shows different types of technologies, their data rates, latency, and spectral efficiency. The table 2 on the right presents the communication technology employed in the development of a microgrid platform, which was done by Lee. So the microgrid uses the traditional Ethernet, which is known for its high speed, reliability, scalability, which enables devices to communicate with each other over local area network. The RS485, second from the list, a serial interface which has a long distance communication capabilities and ability to support multiple devices on the same bus. And then there is the IEEE 802.15.4 standard for low power devices with limited battery capacity and the support for mesh networking topologies. So the microgrid developed by Lee and colleagues requires more than one communication, as it is seen from table 2. So which can be costly for microgrids with a constrained budget. So on this diagram, there's a depiction of a multi-mode, multi-hop strategy for Wi-Fi and Baidu that solves a communication over long distances. This is achieved using the Baidu short message protocol. So the authors concluded that this approach effectively enlarges the coverage area of the grid while reducing cost. However, they also noted the Baidu short message SMS is limited to only 120 characters. The transmitter, again, ensures the transmission of data without guarantee the reception by the receiver. Also, complexity is being added to the system as more than one mode of communication is used. So in this paper, we explore the IEEE 802.15.4 multi-hop wireless network that uses multiple intermediate nodes for more efficient and reliable communication over long distances. The IEEE standard 804.15.4 standard defines both the physical layer and the media access control layer. The routing protocol is will be handled by a ZigBee routing protocol within the ZigBee standard. The mesh network shown here in figure 8 was developed using MATLAB Simulink software, where each block represents a residential unit which has receive, transmit, and reroute capabilities. Figure 9 on the right illustrates the routing block for unit 1. So when data packet is received from the central controller, it contains the source and the destination identifiers. The data packets are then rerouted to neighboring nodes, U12 and U21 in this case. So if the current node is not the intended recipient, that's when the rerouting occurs. This diagram here shows the table, the relationship table shows the connections between the units. Each node periodically broadcasts its position and listens to other messages from other nodes within the communication range. So in this diagram, the central grid management system is wirelessly connected to an intermediate node located at the bottom right, the U33. The message is sent from the central controller and propagates through the nodes and is carried to the destination node as indicated by the arrows. The communication between the central controller and the nodes can be simplified to these two subsystems when simulated from MATLAB. System 1 at the bottom is the residential unit comprising of PV panels, energy storage, and loads. So the solar farm, secondly, is integrated with the energy management system, which is the master controller. Here we have two figures, figure 9 and 10, which depict the waveform derived from the PC microgrid simulation conducted in MATLAB Simulink, illustrating the state of charge of local and solar storage batteries with and without the energy management system, respectively. The energy management system prioritizes charging of local battery, and once the battery reaches full capacity, the surplus power from the PV panels is redirected to the solar farm. This leads to a state of charge for the local system within the EMS integrated units, as it can be seen on these two diagrams. The diagram on the right shows this solar farm, the waveforms without the EMS. So the EMS restricts the supply capacity to allow batteries ample time to recharge local energy storage. So local energy storage is used only after the PV panels stops supplying energy after sunset, as depicted in figure 11 between the times 7 and 8. This capacity restriction ensures the PV systems has enough time to fully charge the batteries. Without the EMS, both battery storage ends with less state of charge. So the two scenarios, as it can be seen here, we have on the left the diagram, which consists of the EMS, and then on the right, as it can be shown, both storage systems are below 50%, which signifies that the EMS on the left is able to limit or to allow the batteries to charge during the day when PV panels are producing enough electricity and power. So the finding presented here in figure 13 highlights the significance of consistent communication between the central controller and the units within the grid. The uncontrolled system is inefficient in using resources and has the potential to collapse the grid. The energy management system provides enhancements to the grid, which goes below or beyond the state of charge. Stability and reliability is also increased. We are currently setting up a multi-hop network within our laboratory's PC microgrid testbed, consisting of 4 units, which are connected to computers for data collection. Utilizing the multi-hop network architecture, our goal is to optimize energy management strategies to improve grid stability and to enhance the overall efficiency of this system. We are eagerly looking forward to a successful implementation and smooth integration of this multi-hop network into our PC microgrid testbed, which will enable us to conduct comprehensive performance evaluation and gather valuable insights for future research endeavors. I'd like to thank these authors for their research in microgrids and communication technologies, which provided valuable insights for our paper. Thank you.
Thank you so much, sir, for your presentation. Ma'am, do you have any questions?
No, thanks, Anshika.
Okay, we'll move on to the next presentation then. Next up, we have our author to present the paper titled real-time vehicle-to-vehicle communication based network cooperative control system through distributed database and multimodal perception demonstrated in Crossroads. Are you there, sir?
Yeah, I'm here. Can you hear me?
Yes, sir, we can hear you. You may start with the presentation, sir.
Okay, let me share my screen for a second.
Yes, sir, you can share your screen.
Yeah, can you see this?
Yes, sir, we can see your screen.
Okay,
You may start.
cool. Yeah. Hello, everyone. Good morning, good afternoon, and good evening. And I'm Jie Wang. You can just call me Tony. I'm honored to be present here, showing our our team works on this real-time system. It is quite a long name, I know, and we basically focus on the communication systems between vehicles to vehicles using the simulation platform, the Quantum card, Q card. You might not have heard it. I can just tell you it's some kind of the physical simulation vehicles that can simulate the complex and dangerous scenario that we may not be able to simulate using the real card or like maybe we cannot achieve in the digital simulation. And here's the outline of today's works. We have several systems, and I'm going to focus on control, sensoring, and communication here. And also, I want to introduce the collision avoidance algorithms. All our project and codes are open source online on GitHub, and let me show you here. If you are interested, just click on it, and okay, I will show it later. Sorry. And here is our motivation. Why do we do this system? It is because sometimes the vehicles are driving in bad conditions. For example, there's no traffic light, road signs falls down, and there's also blind spot because the the construction cause the autonomous driving vehicle cannot see the places in front of it. And so if we add something like that can be remotely connected to each other, like the signal using the microwave, anything like that, we communicate with each other, maybe the vehicles can just avoid collisions. And this is important because it can improve both, at first, safety, second, efficiency. Statistics shows that there's many energy wasting due to the intersection. Intersection is quite important in urban transportation. However, it also causes high probability of collisions. Like, for example, in the United States alone, there's over 43% of crashes happens near the intersection. And there's also more in other cities, even in Singapore, such an advanced transportation system city, also have like a third of the crashes happens each year. And the problems here, we have only many two challenges. First, how can we make sure that the vehicles can know the orthogonal directions vehicles and to avoid a collision? Second, how can we predict the non-motor vehicles and pedestrians coming from the blind spot? And here we illustrate using our platform with the VBCSES. This is a long name, I know that. Here's the overview of our system. You can see here. Since it is a simulated autonomous driving system, we have the high performance server using the 3090 GPU serving as the cloud server. And however, cloud server has a long delay, and since it is remote, we cannot make sure that it is time efficient and safe. So we need the local network to connect different vehicles together. And then finally, we need to deploy our algorithms and the communications on the Q cards. The Q cards I will introduce to you later in details. And you can see here, it has first sensors communicate doing the perception part of the work. It will analyze the physical world around it, and then it will self-driving to cross the roads. And through this, we need to using the distributed real-time database. Like the first here, we choose the etcd. It is very practical and useful here. And here's the Q card. The Q card is like quite small, like this. It is 1/10 scale of the real car scenario, but it is still very powerful. You can see it has LiDAR, radar, gestures, enough GPU, and everything like that. You can just use it to simulate a real world car with a much cheaper price. And here is maybe the more specific identification or like configuration of it. You can check it also on its website. I think it is a good card for simulating. And as for the software stack, which predicts simplified version, it may not be applied to the real world autonomous driving vehicle, but I think that is enough for demonstration in just a crossroad scenario in the lab. And here we used Python, Go, and etcd to collaborate together doing the perception, control, decision making, and maybe the communication through the this database distributed. And here's first, let's introduce the control system. The control to simulate scenario like this, we established a crossroad setup in our lab with the 4.5 squared meters, and here you can see we block the road with the box to simulate the case that the cars may not recognize each other's, so they cannot know what happens in front of them, even with their connections. So they need to just use the digital communications to tell each other, I'm here, and how should I propose and how should I behave in this scenario. And our simplification took these three basic instructions for Q cars. You can see if they do not cooperate with each other, they will crash easily. And as for the sensoring subsystem, we use the RAP LiDAR. You can see here, it can detect the scenario, the object around it, and but it's not enough as it is 2D. We also need a camera for us to further improve it. But the camera has a problem. It has blind plots. The blind points makes it like as you drive in in your daily life, it may be annoying because sometimes you just cannot notice the very specific and very important information around you. So you need to be careful. And we merge this together, and we can achieve a safer and better scenario to track the object around us, like this in the lab. As for the communication, we use the routes to do the to connect the sensors together, and using the remote PC as the server, the cloud server, to do the communication part. And its performance is established using the etcd. You can see here is how we maintain the information. The finished state machine is connected to the environment pool of etcd, and the surrounding object will be recorded into different vehicles and then connect to each other using the finished state machine. And in the last is how do we do the collision avoidance algorithm? According to the local rule, traffic rule requirement, and maybe just your driving ability, how do we make sure that the car can go smoothly and correctly? We choose the FIFO, the first layout algorithms here. Like first, who comes first to crossroads? Who can go across it? Since this scenario, the crossroads is highly less functioning. I mean, there's no traffic light, there's no road sign, there's maybe also some buildings that cannot let the car cannot see each other through the camera. So we make sure that there's a lock. There's not a lock, but a lease-based scheduling subsystem. As we learned it from the operating courses, and then we plan for the speed control and the trajectory management here. And in the end, it works correctly. And here's some of our results. We have the you can see in our paper, there's a Google Drive. You can just click to download it. And here's the experiment, which shows that our control mechanism works correctly with our camera filters and many other techniques I didn't mention here. Further, here's our conclusion. We did a precise speed control, making sure that how to say, the vehicles, it can localize to each other's correctly and move correctly in the demonstrate and the cross-road demonstration. Then we can make sure that the perceptions work correctly, and also maybe most importantly, how do we communicate with each other using the ETCD and optimize the traffic flow here. And that's all. Thank you for listening. Any questions?
Thank you so much for your presentation, sir. Ma'am, do you have any comments or questions?
Yes, I just want to know, you said that it's basically been designed to avoid any sort of collision, right? So,
Yeah.
So is it like suited for the heavy vehicles as well, or is it only for the normal cars or something like that?
Oh yeah, we also created mechanisms for the normal car, but I didn't notice here. Like for examples, there's some yeah, here's a readme for our scenario. There's some cases that the car is normal car and then it don't have an ability. Since it is normal, so we cannot communicate with it, but we can make sure that we need to await the signal and to like maybe for examples, other cars in the back, we can let this let it to signals the message and tell the car to you need to wait for it in some cases. But you know, it is also true that if the road condition is quite restricted, it is still hard for connected vehicles to cooperate with a normal vehicle. Thanks.
Okay, thank you.
Thank you so much, sir, for your presentation. I think we should move ahead with the next presentation. Next up,
Okay.
we have Abdul Rahman to present his paper titled Speaker Recognition with Deep Learning Approaches, a Review. Are you there, sir?
Yeah, hello, you hear me?
Yes, sir, we can hear you. You may start with
Okay.
the presentation, sir.
Yeah, I would like to share with the screen.
Yes, sir, you can share the screen.
Okay. It's okay now? Sharing?
Yes, sir.
Okay,
See your screen. You may start the presentation, sir.
okay. Good afternoon, everybody. Thank you for giving me the opportunity to speak with you today. My name is Abdul. The presentation today will be on speaker recognition with deep learning approach review. We are going to look at how technology helps us to recognize people by their voice. I will talk about the basic, how we use it, and the challenges we face, and review ideas in the field. I'm available to answer a question at the end of the presentation. This study gives us overview of the methods for using deep learning to identify and verify speaker recognition definition and the branches, application and the speaker recognition, the main challenges of speaker recognition. The speaker recognition is like a computer knowing who you are just by hearing your voice. It's like how you recognize your friend's voice on the phone. This technology helps computer understand and identify people when they speak. The speaker recognition also refer to identify the speaker by his or her voice sample. Why today using speaker recognition? Easy to capture sample from the individual compared with other kind of biometric patterns. Most economical among other biometric systems, since do not need to special hardware or capture to a human voice. It's also more acceptable from people. Okay, So slide 2. Okay. Okay. The speaker recognition, like speaker recognition technology, has two main branches: the voice verification, the voice identification. The voice verification, it's like a key that only works within your voice if the voice matches or your end. It's used to make sure you are who you say or you are, like unlocking your phone with your voice. Voice identification. This is like a play guessing game where your computer listen to the voice and it tries to pick who it's blogging from the bunch of people. It's used to find out who is talking without needing to guess. It's a speaker recognition application, forcing application, surveillance application, security and access application, commercial telephone transaction, law enforcement and surveillance. The main challenges of speaker recognition channel mismatch refer to difference between a training and test signal recording a condition due physical factor like change in handset or environment factors such as background noisy, reverberation, and echo. Time inspect effect occurs. The result change the phonation of speaking due changing into environment, illness, speech under stress, aging, cold, short utterance. Like in some case, there is very limited data can be used for the training and testing. The deep learning here, the deep learning overview, the deep learning, a subset of the match learning that leverage artificial network to learn from the large volumes of the data, perform complex tasks with the minimum human interpretation. Unlike traditional match learning approaches, deep learning model can be automatically discovered like patterns, representation directly from the raw data, making the highly effective. The context of speaker recognition deep learning has realized the field by enable more accurate reports and deep learning model can be effect capture and integrate availability present. The feature learning mean deep learning model can learn important details from the spoken words all by themselves. End to the end system, deep learning can take this in-spoken words and directly figure out who is speaking. Convolution or Simon's network. This network help figure out how similar two voice sample are making in the easier to confirm if the speaker is who they say they are. Convolution network using checking if you voice blogging a certain person. Recurrent neural network. It's used to figure out who is speaking when conversation like RNN are great at the understanding the flow of the sound over time. The growing generative adversarial network. These are used to change one person's voice to sound like another, whole, keeping that you are saying the same. They learn how to switch between voice. The conclusion recap the recap of the importance of speaker recognition and the role of deep learning advancing this field. Emphasis and the ongoing research and innovation needed to overcome challenges and further improve speaker recognition system. Thank you for listening.
Thank you so much, sir, for your presentation. Ma'am, are there any questions?
No, thank you, Anshika.
Okay. So I
Thank
would
you.
like to sincerely thank our authors for their excellent presentations and contribution in this session, and for all the participants for being the part of this international conference. I hope the session was informative enough. We, on the behalf of the whole team, thank you for your support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025 as well. All the presenters would be getting their digital certificates through email within the 2 working days. Further, all the papers have been already forwarded to the sponsor. The publication will be live within the 6 months, so kindly cooperate with the team of ICIT 2024. Also, before ending this session, I would like to thank our session chair, Dr. Priyanka Verma ma'am, for chairing this session. Ma'am, this is a token of appreciation to you on the behalf of the team of ICICT 2024 and Global Knowledge Research Foundation. Would you like to share a quick ending remark with us?
Thank you, Anshika. It indeed was a wonderful session, and all the presentations were really good. They were actually quite information conveying.
Thank you so much, ma'am, for being in the session, for your valuable presence. Also, I would request everyone to open their camera for a quick snapshot before we end the session. Thank you so much, everyone, for your valuable presence. We hope to see you again soon. Thank you so much, ma'am.
Thank you, ma'am,
Thank
once
you.
again.
Bye-bye.
Thanks a lot.
Thank you.
Thank you. Thank you.